Today we're going to do 5-8, which is applying special right triangles. We're going to start off with some math humor. How do you rationalize a denominator? Ask it to be reasonable. So what are we going to learn today? Today we're going to talk about, we're first going to start off with a 45, 45, 90 triangle, and then go on to the theorem and then an example. Then we're going to talk about a 30, 60, 90 triangle, a theorem, and example. So there's two theorems we're going to talk about and two different types of triangles we're going to talk about today. So what is a 45, 45, 90 triangle? We're going to start it off actually with a square. Now about this square, we should know that all the sides are congruent because it's a square, and all of the angles are right angles, or 90 degrees. Now to go about this to form our 45, 45, 90 triangle is we take a line called a diagonal and we go from corner to corner. What we've just done is that we've created a triangle down here. In fact, we did make two triangles, but we'll just talk about this one. So we don't need to concern ourselves with any of this at all. But what's important to note is that two of the sides are still congruent. You have congruent and congruent, because that's because it's formed from a triangle, or a square, I'm sorry. So now, why does it have the name 45, 45, 90? Well, when we made that diagonal, we bisected our angles, meaning that we now have a 45 degree angle here and a 45 degree angle here. So what we're looking at is a 45 degree, 45 degree, 90 degree triangle, and that is a 45, 45, 90. This leads us to our theorem 5-8-1, which is the 45, 45, 90 triangle theorem. In a 45, 45, 90 triangle, both legs are congruent, and the hypotenuse is the length of a leg times the square root of 2. What that means is that if we had a triangle, of course it has to be a 45, 45, 90 triangle. So let's go ahead and label this as 45 and at 45, and we have our right angle here. Let's just say that we had a side length of 10 square root of 2, and what we are looking for is your side length right here. We're asking what is that side of the triangle. So we can use this theorem directly, and it says both legs are congruent and the hypotenuse is the length of a leg times the square root of 2. So it's important to note first that you have 10 square root of 2, therefore you're going to have 10 square root of 2 here as well, because they are both legs. These two segments are congruent. Now what is x? How do we find x? Well, we know the hypotenuse is equal to a leg times the square root of 2. Or in other words, x is equal to, well, what's the length of a leg in this case? 10 square root of 2 times the square root of 2. Simplifying further, x is equal to, now we need to multiply. 10 is the only number on the outside, so 10 is going to be stuck on the outside of the square root. And now in the square root you have a 2 times a 2, meaning a 4. Now you might think we're done, but don't we know the square root of 4? The square root of 4 is 2. And so this is that situation where we can pull the 4 out and it turns into a 2. So this is the same as 10 times 2, or in other words, 20. So x is equal to 20. Although we just kind of did an example, here's another one. It says find the value of x, and we are given the following triangle. You're given a right angle there. You're told x, x, and 5. Now we're not really told if this is a 45, 45, 90 triangle or not, but because these are both x's, because these are the same length, we can call this an isosceles triangle, and therefore these two angles will be congruent, meaning they would be 45. It's 45 and a 45. So we do have a 45, 45, 90 triangle here. And now we're looking for x. Is x a leg or a hypotenuse? Well, it's a leg, but using our theorem, we know the hypotenuse is equal to a leg times the square root of 2. Well, we know the leg is x, so we have x square root of 2, and the hypotenuse in this case is 5. So solving for x now, we need to divide by the square root of 2, divide by the square root of 2, and you're left with x is equal to 5 over the square root of 2. We're done now, but if you think back, simplest radical form, we have to do a little bit more. You have the square root of 2 in the denominator, and therefore you need to get him out of the denominator. We multiply by square root of 2 on the top and the bottom to be left with. You need to think, is 5 on the outside or the inside? It's on the outside. Is 2 on the outside or the inside? It's on the inside. So you cannot touch them together. It's stuck as 5 square root of 2 over. And now 2 is on the inside and 2 is on the inside. So it's 2 times 2, which is 4. But you know the square root of 4, so this turns into 5 square root of 2 over 2. And that's because this 4 turned into the 2. And now we are done. This is our final answer. This is the length of a leg. Now we're going to talk about a different type of triangle, and it's a 30, 60, 90 triangle. So to come up with a 30, 60, 90 triangle, we're going to start with an equilateral triangle. Equilateral triangle means that all the sides are congruent, right here. And in fact, all of the angles are congruent. So every angle is 60 degrees. Now what we're going to go ahead and do here is we're going to take a line and we're going to drop it down from top to bottom, from that top to the base. And so the triangle we're talking about is actually just the right hand triangle. It could have been the left hand, but this is a 30, 60, 90 triangle. The reason why was because this 60 degree angle just got cut in half. We just drew a line down the middle, and so it just got cut in half, so it's no longer 60, but it is now a 30 degree angle. And now we have our right angle as well. So what we have is a 30 degree, 60 degree, 90 degree triangle. This leads us to theorem 5-8-2. It says that in a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg. And the length of the longer leg is the length of the shorter leg times the square root of 3. So that sounds pretty confusing right now, but let's go ahead and look at a 30, 60, 90 triangle. It's going to look something like this, where we have our right angle and we have our 60 degree angle and then our 30. Now we're talking about the length of the sides, so let's just say that this bottom side is the length of 1. Let's make sure that's a 1. This is obviously the shorter side, but it says the length of the hypotenuse is 2 times the length of the shorter leg. Well, the shorter leg is 1, so it means that the hypotenuse is going to be 1 times 2, or 2. The length of the longer leg is the length of the shorter leg times square root of 3. So the longer leg is here. It's whatever this length is times the square root of 3. So it's 1 times the square root of 3, or simply square root of 3. This triangle here, with these exact side lengths, is the most common 30, 60, 90 triangle. Now we are told for our next example to find the values of x and y. And we're given the following triangle with a right angle, and then we are told that this here is a 60 degree angle with x, y, and a hypotenuse of 18 square root of 3. So finding the values of x and y, I'm going to start with x because it's the shorter side. Always start with the shorter side. And from our theorem, what we know is that the hypotenuse is equal to the shorter side, so I'm just going to label that as short, times 2. Well, we don't know the shorter side, so let's say that this is equal to 2 times x. The shorter side I'm calling is x. And then we have our hypotenuse of 18 square root of 3. Now solving for x, we can divide both by 2. And notice that the 2, same story, the 2 is on the outside and the 18 is on the outside. So we can divide 18 by 2 to be 9 square root of 3 is equal to x. And now that we know the shorter side, which again is 9 square root of 3, now that we know the shorter side, we can find the longer side, which is y. The longer side, and this is from our theorem again, longer side is equal to the shorter side times square root of 3. So we don't know the longer side, so y is equal to the shorter side, which we just found was 9 square root of 3. So 9 square root of 3 times the square root of 3. So we have y is equal to, now we have to multiply. 9 is on the outside, 3 is in the inside, and 3 is in the inside. So we get y is equal to 9 square root of 9. But we know the square root of 9, so simply this is the same as 9 times 3, or in other words, 27. Now it's time for a hard example, and I'm sorry about the length of this video, but I thought we might as well do this one because it's pretty difficult. We want to find the perimeter and area of the figure, which is an equilateral triangle with height 30 yards. So we need to draw that first. Draw this equilateral triangle, but notice it says a height of 30 yards, meaning, again, it's equilateral. A height of 30 yards, meaning what we're actually talking about is we're going to drop a dotted line, and this dotted line is the one that's 30 yards, not the sides of the triangle. Now what we need to realize is, let's see, how do we find area? Area is equal to 1/2 base times height. Well, we know the height of the triangle, so we need to find the base. We need to find the length of this guy right there. Well, what I can notice is that to the right or the left, we have a triangle formed, a smaller triangle. And if you remember back from what is a 30, 60, 90 triangle, this is a 30, 60, 90 triangle. Because it was an equilateral triangle, we still have a 60, and we bisected an angle to be 30 degrees. And then we have a right angle. So we have a 30, 60, 90 triangle. So we need to decide what the length is of this bottom side. How to do that? Again, we know that well, let's see what we know. We know the 30 right there, the 30 yards. Is that the hypotenuse? No. It is the longer side. So we know that the longer side is equal to the shorter side times the square root of 3. So we have 30 is equal to, let's call it square root of 3 times s. Let's solve for s now. We divide by the square root of 3, divide by the square root of 3. So you have s is equal to 30 over the square root of 3. But we need simplest radical form, so we multiply it by the square root of 3 over square root of 3, giving us 30 square root of 3 over 3, which reduces down to 10 square root of 3. Now what is key is that 10 square root of 3 is just here in this 30, 60, 90 triangle. That is not the entire base. What the entire base is 2 times this. So it will be 2 times 10 square root of 3. So we have the base is equal to 2 times 10 square root of 3, or in other words, 20 square root of 3. So the entire distance of our base is 20 square root of 3. So our area is equal to 1/2 base, which is 20 square root of 3, times your height, which we knew was 30. And now we can multiply across, and we're going to get 300 square root of 3. And this would be our area then. And now all we need to find is perimeter. But the perimeter of a triangle, especially equilateral triangle, aren't each of the side lengths the same thing? Because it's equilateral. Each side length is 20 square root of 3, 20 square root of 3, and 20 square root of 3. So we can simply say the perimeter is 3 times 20 square root of 3, or in other words, 60 square root of 3. Again, I'm very sorry this video went so long, but this example I felt was most definitely worth doing. So good luck. Write down any questions that you have, because I know this stuff can definitely be difficult at times.